Hello everyone, I'm Shogun. Okay, let's continue looking at these simple introductory cases. In these lessons, we'll look at the player-controlled camera. It actually controls this pump while also controlling the camera. We can take a quick look at this video. You see, you can control this QB through WSD and at the same time rotate your camera. The creation process is also relatively simple. I believe everyone has done this kind of work in Blueprint. But we mainly want to see how Unreal Engine does it. Here, first create a project, then C++. And the way it creates C++ classes is a bit different. This time it is created through the C++ class interface at this location. After creation, it specifies its subclass. It places its class under this module. Yes, and at the same time here, it adds a SpringArm component, which is a camera SpringArm. Yes, then it adds a camera component. Then it is in the static mesh. Note that it uses a forward declaration here. We have mentioned that forward declaration is a very good habit, because it avoids directly including the file where this class is located in your header file, and it can avoid some issues with duplicate includes. At the same time, it can speed up your compilation. Of course, we also mention if we include a structure with reflection, so using forward declarations is unwise because some reflection files are not properly included. So here, a SpringArm is created. Then a component is bound. So how do we bind them in? First, since you are using this component, you need to include the header file in our source file. Note that this is now the source file, and here we still adopt the default approach, because we are creating this object in the constructor. So we can directly create this default sub-object. So here are the scene components respectively. So it counts as you creating a scene component, and at the same time here, its static mesh component is created at once. Then the SpringArm component, then the camera component, then this place. We just created these components in the scene. These components actually don't have dependencies on each other yet. So let's first take this static mesh, attach it to the root component, then attach the SpringArm component to the static mesh, then place the camera component on the SpringArm component. And note that there is a socket name here, and here it should have taken a default value. After attaching, it made some settings for this SpringArm here. Some initial value settings, for example, angle. This enables the follow delay of the SpringArm. That is, when we often follow the camera, you will notice that the camera has a follow delay to make it smoother. And here there is a feature. It uses AutoPossessPlayer, which automatically accepts player input. This means it does not specify a character base from our game mode after the player logs in, and then let the player process it. Instead, it directly has such a class in the scene, and this class directly accepts control from the local player. Now let's take a look here. So then it has this pawn, but this pawn cannot yet respond to its input. So we need to do some work to respond to input. So this is a piece of code that it has already completed. You can see it looks roughly like this. Okay, good. No problem. So how do we do small scale input? So here, it still uses an old style mapping from UE5. Wait a moment. It should be in this chapter or the next one. We will show you a simple operation of enhanced input. So in this bullshit-free free zero, find the input class. And here there are two input methods. One is action. One is action and one is access mapping. So here it is, binding a right mouse button. Just click one, that is to say. And at the same time, binds tag OAS and then binds the camera's horizontal and vertical movement. Yeah. Once the bending is done, then in the C++ code, it can respond to these several types of mappings. Set in the editor. First, it prepares several variables. These variables are respectively movement, input, camera input, and this zoom in, and this boolean. We'll know once we take a look. Then here, this is the corresponding response function. So first, how are these functions defined? They are. This is a fixed function in the form of a signature, and because this is an input, you just made some bindings in the editor. In terms of reflection, C++ must correspond to this form. So, this forward is what happens after you press WASD. It will pass this value in. Then after it is passed in, it copies this value here. It uses these variables to receive it. So this place is obviously receiving a two-dimensional vector xy for movement. Then camera xi. Then this room in and room out are a Boolean reception. This one, it should be room in, room out. 质, it can be determined in text. So these two will be discussed later. Here it puts this value into this two-dimensional vector. Then after having the 2D necklace, this place is for binding. Binding the settings we just made. So this place, this is press and release. Then the village corresponds to. This should be zoom in and zoom out. And this place is called every frame. This is the action binding time. This is an axis binding time. So this place is forward. Forward actually represents forward and backward. Left can represent left and right. And this is the camera's pitch and yaw. Okay. Then and ticket will determine. Is this value pressing it will zoom in, so it will zoom out. Then here, with this room of factor, it first clumps the value between 0 and 1.0. Then here, pressing it does an increase and a decrease to quickly reach the upper and lower limit values. Then here, it uses the FOV in the camera component. Originally, it used foo to adjust the camera view. Then here, there is a room of factor to make some adjustments within it. Then here, it does an interpolation between 60 and 90. An interpolation between 60 degree and 90 degree FO. At the same time, the length of the camera arm also undergoes a simple interpolation. Then this place emphasizes, because this is a kind of hard coding we are very familiar with. Every time you change it, you need to recompile with us. Actually, this will cause us, because these parameters are actually in our development process, all adjusted by these designers or artists. They adjust them, that is, we blueprint programmers set up these business logics. Then you, the artist, think this distance is 200 or 300. Don't tell me I set the range for you. Its basic range is 100 to 500. Then you can freely choose the distance during testing. So they need to expose these parameters. Then below, here is to modify the actor's rotation. And this precise rotation. It first gets the current rotation. This is the current rotation value. Then add our camera input to it. Finally, set it back. This is the set Y value. And this sets the P value. Note this. This P value sets the spring. This is what's it called? This is called the spring arm. That is, its spring arm is used to adjust the bell P value. Then this is an object for the camera. Make a simple adjustment to that T out. And here it actually means, here it is for this. The movement of the mouse we input. First, it needs to be amplified, because if you don't amplify it, this value is too small. You might not be able to perceive it. So first, amplify this value. Then after amplifying, we get the current object, its current orientation. Then add the mouse input. That is the x-axis input of our mouse. Then currently, this is equivalent to the right side. That is a direction to the right. Then combined with the mouse's y-axis input. So in fact, the positive and negative of our x and y axes. Then right, this achieves our YESDIO, tri-dimensional movement. Then finally, set this action. Afterwards, we can take a look. There should be no issues here. Let's continue looking at the rest. Then finally, it has already created a C++ class, and here you can add a static mesh. Then you can see some preset parameter values that have been set. You can make further adjustments in the blueprint. It's also not a problem. Then the final adjusted effect looks like this. Then at this point you are moving the mouse, and this is WASD. Actually, what is this class? This class is actually very similar to our DefaultPawn. Yes. What is a DefaultPawn? That is, if you open a new viewport, you do nothing. It will generate a DefaultPawn. And sometimes people ask why in the scene. There is an extra small black ball or small gray ball. Well, it's actually the default pawn. How do you hide this default pawn? You can actually modify the pawn that it generates by default for the player. Or you can just turn off this ball directly. Then what you generate is a player monitor with nothing visible. This is a zoom in and out. Okay, in the end, its code actually looks like this. Let's take a look at what it added. It actually writes a lot of logic into this tick. Normally, when we handle player input, we wouldn't write it this way. Yes, it is actually receiving input here, receiving input to modify this value. Then tick monitors this value. This is also a relatively common approach. Okay, so here it adds some extra stuff. Alright, let's ignore it. This is modifying its movement speed. Things like that. Then or adjust some modes of our camera. Adjust the feel. Actually, this is the entire design of our 3C. If you reset the 3C, in fact, most of the time, you are doing this kind of feel refinement and adjustment. Okay, we'll stop here for this simple document. We'll do a practice session in the next class.